Hello class, we're on 10.4 now, we're on common logs. First of all, we're just going to explain a little bit about what common logs is. So we're going to have a couple of pages of just terms and stuff like that. Base 10 logarithms are called common logs. They're so common that we don't even write the base. So instead of writing like log base 10 of 3, it's just log 3. We just assume that the 10 is here. It's kind of like saying, oh, the square root of 5. It's not like we put the 2 right there. It's just understood that the 2 is right there because it is the square root. In the same way, if we write, log 17, you just assume that the 10 is there. Okay? So, moving onward, when no base is given, like I said, we just assume that the base is 10. The book, it was this base 10. They're so common that this book was made for people who do a lot of math, engineers, statisticians, so on and so forth, that would solve math base 10 problems. Fortunately for us, with the technology that we have, our TI-84 is very, very valuable in this lesson. They have the whole book stored in its calculator memory, so we're going to be using that on every problem today. So make sure if you don't have that out in front of you, pause the video, go get your graphing calculator and come back, because we're going to use it, like I said, on every single problem. So this is like saying a log base 10 of 3, but like I said, we never ever write that down. So log 3 enter is 0.4771. It looks like this. Log of 3. So you just press the log. It's on the left column. Log, it's right next to the 7 of 3. Close parenthesis. Logs are always rounded to 4 decimal points. So 0.4471. We always round it to the 4th decimal point. Okay? So, there we have it, 0.4771. Log of 2, enter, you'd get 0.3010. Moving onward, how does this help us? If I wanted to solve 3 raised to the x equals 11, I can't get common bases to solve for this. So the one thing I can do is I can take the log of both sides. If I do this, class, I'm not breaking any math rules. It's kind of like saying if you multiply on one side, you have to multiply to the other side. If you subtract something from one side, you have to subtract to the other side. If you take the log of one side, then you have to take the log of both sides, and then you're not breaking any math rules. So I can take the log of 3 raised to the x, that's what this is, and the log of 11 and get this. So, which can simply be written something like this. So then what could happen? I could bring this x out front as a coefficient, as we learned from yesterday's lesson. So now I have x log base 3 equals log base 11. And then I could divide both sides by log base 3. And so when I do that, I get this. And this I cannot do unless I have my calculator. So you're just going to press log 11 divided by log 3. Let me show you how that's done. We have log 11. Make sure you close a parenthesis right there. If you do not, you will get a wrong answer. So it's log 11 parenthesis divided by log 3. Close parenthesis again. Oops, press 33. And enter, and you get 2.8127, rounding to 4 decimal places. So 0.21827. Okay? So that's the basics behind this. So, moving on to our first one. I have 10 raised to the x equals 2. I can't get common bases to solve for x, so I have to take the log of both sides. So I have log 10 raised to the x equals the log of 2. Remember, these are always base 10. I don't have to write 10 right here, and I don't have to write 10 right here, because you just assume, whoopsie, that it is 10. Log base 10 raised to the x equals the log of 2. So now I'm going to use my power property. You're going to use this one a lot today. This is going to come forward. So it's going to be x multiplied by log of 10 equals the log of 2. I want to get x all by itself. I want to solve. So if that's the case, I'm going to divide both sides by log 10. That would take care of this. I divide both sides by log 10. So now I successfully have x all by itself on the left. On the right, I have log 2 divided by log 10. Log 2 divided by log 10. And what is my answer? My answer is 0.3010. 0.3010. And class, because I'm rounding, it's an approximate value. So I can't say it's exactly equal to it. So I'm going to use the two squiggly lines, and I want you guys to do that as well. It's approximately equal to, instead of this equal sign here, it's approximately equal to, what did I say again? 0.3010. 0.3010. And this is my answer. So this is an equation. Any equation, I could always check my work if I wanted to. I can substitute x right back up to the top again. So what did I get for x? 0.3010. Let's check our work. 10 raised to that power, does it give us 2? Or at least close to it because it's an approximate value? 10 raised to the 0.3010. When I press enter here, I should get the number 2 or really close to it. 0.199998. I would say that's pretty stinking close to 2. So my work checks out, and I could do that on every single problem. So hopefully that's reassuring for some of you who are kind of fuzzy on this stuff. You can always check your work. You guys try this one on your own. How did you come out? All right, you should take the log of both sides. Log base 5, the x is going to come in front as a coefficient. That equals log 9. So x equals log 9 divided by log 5. When you do that in your calculator, hopefully you got the number. X is approximately equal to 1.3652. 1.3652. All right, the process is going to remain the same for all these problems. We just get a step higher in difficulty level with each problem, basically. So this one, I have a binomial as my exponent. But it's going to remain the same. I'm going to take the log of both sides. So it's the log of 3.1 raised to the a minus 3, but I could bring that in front as a coefficient. So a minus 3 comes out in front, times the log of 3.1. That equals the log of 9.42. So now what I'm going to do here, class, is I want to get a minus 3 all by itself on the left. I'm going to get rid of the log of 3.1. Right now it's divided. Right now it's multiplied. So I'm going to divide both sides by the log of 3.1. That would eliminate it from the left, and then I would just be left with a minus 3 on the left. On the right side, I have the log of 9.42 divided by the log of 3.1. What is that? Let's put it in our calculator. Log 9.42, close the parenthesis, divided by the log of 3.1. And I get the number 1.9824. 1.9824. 1.9824. And now, instead of equals to, it's not exactly equal to it, it's approximately equal to it. So I'm going to have those two squigglies. And then how do I get a all by itself? I simply add 3 to both sides. So my answer is a is approximately equal to 4.9824. And as I said, on every single one of these, if you want to check your work in your calculator, you're more than welcome to do that, and you will get the left side equal to the right side if you did it correctly. You guys, try number 4. How did you come out? Here we are. Log of 2.3. The x plus 4 is going to come out in front as a coefficient. That's going to equal the log of 7.56. 7.56. So then what you did is you took the you divided by the log of 2.3, and you got x plus 4 on the left, and on the right you had an approximate value of 2.4287. 2.4287. So then you subtracted 4 from both sides. subtract 4, subtract 4, and you got x to be approximately equal to the answer of a negative 1.5713. Class, I can never take the log base of a negative number. However, this is an exponent. Okay, I'm putting it back into an exponent, and you can have negative exponents. That's just fine. So in this one, you don't need to worry about your negative answers. So that is the answer for problem number 4. Problem number 5. This one, slightly more difficult again because we have a binomial on both sides. So the process is going to remain the same, but it's going to be slightly more difficult. I'm going to take the log of both sides. Hiya! Log 6 raised to the x minus 5, but the x minus 5 is going to come out in front because I'm going to use the power property. That equals the log of 2 rats. I'm going to put the 7x plus 2 out in front, then multiply it by the log of 2. What I did here, class, was I took the log of the right side, but then moved this out in front. Okay, so what I'm going to do here is I have a product on the left and a product on the right. So somehow I got to get one of these parentheses all by itself. I'm going to divide both sides by the log of 6, because that would take care of this at least. And now I'm going to divide by the log of 6 over here. So now, good news, I got x minus 5 all by itself on the left. Now I have 7x plus 2 multiplied by this mess. Okay, what is this mess? Let's put it in our calculator. Log 2 divided by log 6. Log 2 divided by log 6. And we have the number 0.3869. 0.3869. 0.3869. And once I round it to a decimal, instead of putting equals, I should put approximately 2 to make it mathematically correct. So hopefully that makes sense so far. I haven't lost anyone yet. I'm just checking my work on my notes to make sure that I did it right. Oh, is this supposed to be a negative number? Okay, class, we're looking good. So now, here's what we have. And now what we need to do is we have to get rid of these parentheses. People get kind of overwhelmed by this number right here. But all it is just, I mean, it's a single number. It's like 3 or like 7. It's just a decimal number is all it is. So I'm just going to distribute this decimal answer. So 7 times 0.3869. 7 times 0.3869 is 2.7083. 2.7083x, and then 0.3869 times 2. 0.3869 times 2 is 0.7738 plus 0.7738. That equals x minus 5. So now I'm going to get all my x's to one side and all my numbers to the other side. I'll probably subtract 1x here. Subtract 1x. So 2.7083 minus 1. 2.7083 subtract 1 is 1.7083. Probably could have done that one in my head. 1.7083x, and then I'm going to subtract 0.7738 from a negative 5, 0.7738, to get a negative 5.7738. Whew! And then lastly, I'm going to divide both sides, and I got to get in the habit of doing this. This should be approximately equal to. Lastly, I'm going to divide by 1.7083. 1.7083. And when I do that in my calculator, negative 5.7738, negative 5.7738 divided by 1.7083. 1.7083. My answer for x is going to be a negative 3.3799. Negative 3.3799. See if I can remember that. Negative 3.3799. Negative 3.3799. And there is my answer for x. Approximately. X is approximately equal to that. So hopefully that makes sense. I'll go through this next one with you as well to make sure that we all get the right answer for the next one. Okay, class, we'll try this one all together now. So what we're going to do here is we're going to take the log of both sides. So log 3 raised to the 2x plus 3, which means the 2x plus 3 comes out in front. That equals the log of 7 raised to the 4x minus 6, and the 4x minus 6 comes out in front. So now what we're going to do is we're going to divide both sides by log 3. Because if we divide both sides by log 3, then on the left, all we have left is 2x plus 3. And on the right, we have 4x minus 6 multiplied by the log of 7 divided by the log of 3. So we're going to do that in our calculator. Log of 7 divided by log 3. Rounding to 4 decimal places, you should got 1.7712. So once we have that, now we're going to distribute. You're basically just solving an equation with a 4 decimal distributive property. So we have 1.7712 times 4 is 7.0848 x minus 1.7712 times a negative 6, which is a negative 10.6272. That equals 2x plus 3. Okay, I think I'm going to subtract my x's to get them on the right side again. So I have 7.0848 subtract 2 gives me 5.0848x. That equals, and I'm going to add 10.6272 to both sides. So 3 plus 10.6272 is 13.6272. And lastly, to get x all by itself, I'm going to divide both sides by 5.0848. $13.6272 divided by 5.0848, and I get my answer as being x equaling to 2.679, I guess it would be 6800. And you could always check your work with these, class. And once again, I made that stupid mistake. Approximately equal to, approximately equal to, and approximately equal to, and approximately equal to. So feel free to check your work with any and all of these, class. I really encourage that, especially on a test.